Our next unit is Unit 3, M plus B and graphing linear relationships. When we are graphing, we have to remember that there's 4 types of slopes that show what our graphs do that we're going to see in this unit. The first one is a positive slope, and remember that positive slope goes uphill from left to right. So if you're reading a book, you always start at the left and go towards the right and read. Same thing with a graph. You always start at the left and see what your graph is doing, and this one is going uphill. A negative slope goes downhill, okay? So from left to right, it goes downhill. A zero slope has no movement. It's like you're stopped, not moving. And an undefined slope is straight up and down. So we have learned how to find slope many different ways. We've learned from a table, we've learned from a graph, and we've learned from points. To identify a slope from a table, we always find its jumps. So we would say, how do I get from -1 to 0? So we would say, oh, you don't plus 0, you plus 1. How do you get from 35 to 40? Well, we plus 5. So to find our slope from a table, you always take the change in y and put it over the change in x. So this is our change in y, our jump on our y side, so that's going to be our numerator. And our change in x is our change in our jump on the x side, so that's 5 over 1. You can leave it as 5 over 1. You could bring it down to 5. That's totally fine. Our y-intercept, we always look to find where x is 0. So x is 0 and y is 40, that is going to be our y-intercept. So 0, 40, remember our y-intercept is a point on the graph, so we always must include 0. When we find slope from a graph, we're going to use rise over run. Rise over run. So rise is either up or down. Run, we move to the right. So you can pick any 2 points you want on the graph and you count. Okay, how do I get from this point A to point B? We're going to move down 1. Down 1 is -1. And we're going to move right 3 units, which right is always positive. Rise over run. So our slope will be -1 over 3. Look to see if you can simplify your fraction. If you can, do it. If not, it's okay. This is where you will stay. Your y-intercept is where the line crosses the y-axis. So at this one, we actually used that point in our slope, and that's point A. See how the point is on the y-axis. So that point is located at 0, 6. Again, putting your 0 in the ordered pair. The last way we found the slope was using 2 points, and we had a formula for that. It was y2 minus y1 over x2 minus x1. This is the formula we're going to be using. So when we do this, we can label our points. Pick a point to be x1, y1, pick a point to be x2, y2, and all we have to do is substitute in. Our y2 value is 15, so we'd say 15. In the formula, it's minus, so we subtract our y1 value, which is -3. Our denominator, x2 is 4. We subtract, because that's what is in the formula, our x1 value, which is 2. Now we've got a double negative, so we have to make them positive. So 15 plus 3, 15, 16, 17, 18. And then 4 minus 2 is 2. We have to continue to simplify as much as we can. So 18 divided by 2 is 9. So the slope in this problem would be m equals 9. We're going to do another one, just because formulas are a little more difficult. Label your points x1, y1, x2, y2. So again, we just substitute in. y2 is -2. Our formula says minus. y1 is 5. Our denominator, x2 is 8, minus x1 is 2. No double negatives here in the middle, so we're just going to simplify. -2 plus a -5 is -7. 8 minus 2 is 6. I can't simplify that anymore, so our slope is -7/6. When we are graphing, we also have to set up function rules. So this is kind of the same as what we did in Unit 2. So here we have Jason is ordering a bouquet for his girlfriend for her birthday. There's a base fee of $6 for the bouquet and an additional $1.50 per rose he adds in. Write a function rule that models the situation and identify the slope and the y-intercept. So we're going to look for the cost of what his bouquet is going to cost him. First, he's got to have the basic bouquet for $6. Plus, he's going to be charged $1.50 for every rose that he puts in. Now, our slope is what changes the overall cost. So our slope is $1.50. Remember, you do not include that variable. It's just the number in front of it. And your function, your y-intercept is where you start. So it's going to start at 0.6 because he has to start paying $6 for that basic bouquet. So it's $6 plus the $1.50 R. This is where you're going to start. This is what changes. So it's going to move your graph. Now let's actually graph some lines. Here, again, y equals mx plus b. This right here is always your slope. And then the number that stands alone is always your starting point. So our slope in this problem is 3.5. Our starting point is 0, -2. Again, starting point, we have to include the 0. So we start on the y-axis at 0, -2. Our slope tells us we're going to move up 3 and right 5. So we're going to go up 1, 2, 3, right 1, 2, 3, 4, 5. Do it again. 1, 2, 3, 1, 2, 3, 4, 5. If you like super accurate graphs, you're going to say, well, I ran out of space. So we can go the other direction. Since we went up 3, right 5, we could go down 3, left 5. Okay, so it should always line up with the rest of your points. We want a nice, straight, accurate graph through those points, extending all the way through the coordinate plane. The next one here is not in that graphing form, so we do have to do a little bit of math. We have to get y alone. And remember, in order to get y alone, the first thing we do is move our x. So I'm going to move x to the other side. I notice that this one has a variable, but this one doesn't. So I'm going to separate them so I know not to combine them. So we say -3y equals, this doesn't have a like term, and neither does the 6x. So just bring both of them down. Y still is not alone, so we're going to divide everything by -3. These will cancel. You're left with just y. -18 divided by -3 is a +6. 6 divided by -3 is a -2x. So again, the number next to your variable is always your slope. So this one is -2. But because we're graphing, let's put it over 1 so we remember to move to the right 1 unit. Our starting point is 0.6. So let's get to graphing. We start on the y-axis at 6. Okay, remember we always start here on this line. And on this graph, it tells us we're going to move down to right 1, down to right 1, down to right 1. And this one, we have a nice straight line, and we're done with that graph. The last type of graph we have seen, we saw was two special cases. When we have just x equals 8 or y equals -3, these are either horizontal or vertical lines. Now remember, when we have horizontal or vertical lines, if you cannot remember which one they are, create a table, and this says that every x value has to be 8. So we can just throw a couple 8s on there. Now for y, it doesn't matter what points you choose. I'm just always go to 0, 1, and 2. So if I graph these points, 8, 0, I move over to 8, 0, 8, 1, 8, 2. It shows me that this is a vertical line. So I'm going to connect those dots, one side of the coordinate plane to the other. And an X graph always gives me a vertical line. And remember, a vertical line has an undefined slope. For Y, this same thing, we can create a table to figure out if it's horizontal or vertical, but this one, every Y value has to be -3. So again, it doesn't matter what points you put into X, but we can have -3 here. So let's graph those 3 points, 0, -3, 1, -3, 2, -3. Look at this. You've got a horizontal line going from one end to the other. Hopefully it's a lot straighter than mine, but a Y graph will always give you a horizontal line, and a horizontal line has a slope of 0. Go ahead and work on the homework associated with worksheet 3, or sorry, unit 3, and we'll move on to unit 4 soon.